Hello class, I wanted to give a quick lesson on a couple of these homework questions. Some kind people let me know that I didn't necessarily explain all of these things. So 1 through 7, you're supposed to do the odds. So these are really just the reverse of what you would have or what you need to do on these, which there were examples of 9 through 15. Ones like that. So it's just actually what we do is we call this expanding. So we're expanding the logarithms using the rules of logarithms, and this is condensing. And they're just reverses of each other. One's going one direction, one's going the other. So let's take a look at number 2. So this is log of b to the 4th. Now, there is not a base written down here, so we know it's a base 10 if there's no base written down here, and they did that for all those 1 through 8. And so what we're going to do here is we're going to use the rule where this exponent comes out front. It's the power rule. So this is 4 log of b. And let's go ahead and look at number 8. It's a little more complicated, but I wanted to show you it has this cubed root here. And so for number 8, it's the cubed root of b squared. And in chapter 7, we learned that we can write radicals. So here's a radical, the cubed root of b squared. We can write them as fractional exponents or rational exponents. So this is b to the, and remember this number goes in the denominator and this number goes in the numerator. So this is log of b to the 2/3, which now once again we can use the rule where this comes out front. So this is 2/3 log of b, and that would be the answer for number 8. Number 7 has a few different things that you're going to do to it. You want to change it to the 1/2 power, but then you can also do some things with that. So you can use your exponent rule here. So this would be a to the 3/2, b to the 1/2, and then you can use your product rule. All right. The other ones I wanted to look at were down here. 27 to 33, I think, were mentioned. I didn't show how to do these. These I think you could do if you thought through this. The idea for this group is you want to have the log base of, so let me teach you this principle first. If you have log base b of x is equal to log base b of y, notice x would have to equal y. So if you have logarithm with a base of something, same base equals something else, then actually this part right here is called the argument. X would have to equal y. The arguments have to be equal to each other. So your goal for these would be to get it in a form that looks kind of like this. So I'm going to do 28. 28 is log base 5 of x minus log base 5 of 3 equals log base 5 of 8. And it's not quite in this form yet, but what we can do is we can use the quotient rule to condense these. So this is subtraction. So we can write this as log base 5 of x over 3 is equal to log base 5 of 8. And now we have a log base 5 of something equal to log base 5 of something else. So the arguments have to be equal. X over 3 must equal 8. And now we have a nice simple equation to solve. You multiply both sides by 3, and you get x equals 24. So that's the concept that you need to use for working through 27 to 33, the odd. Sorry that wasn't shown earlier. I know some of you probably read back in your book or figured out somehow, but I wanted to throw that video up there for you.